Time for a new section. 3A is going to focus on percentages. It is going to assume you know some things about percentages, and some of you may need a little more practice than what's in this section. Some of you may need a little less, especially than in this first video. So remember, that's the joy of this being lecture. You can watch it double time. You can watch it over and over and over again. You can skip ahead to the last example if that's all you feel like you need. But before you skip, I want you to stick with me right here for this. So let's start with hurting our brains. The interest rate on an auto loan has increased 50% over the past decade and now stands at 12%. Not the number you were expecting, huh? Is it possible? Well, I'm going to go ahead and save you that question. Yeah. But then what was the interest rate a decade ago? I want to see if you can think through that. The answer is 8%. It was 8% a decade ago. What in the world? Because from 8%, I've added half of 8%, which is 4%, and got 12%. Now, I generally can't add percentages. That's really gray territory. But here they are, both of the same thing, which makes them like terms and blah, blah, blah. So, 8%. Isn't that weird? What did I want you to take away from that? Not that you hate percentages or that you're in the wrong class. I wanted you to take away the fact that there are multiple applications of percentages. And that in there is one of the struggles people have with percentages. I can state them a lot of different ways. I have to make sure I'm stating clearly which one of those it is. So generally, though, all percentages are going to fall in one of two things. They're going to be the percent of another number. So if they're percent of another number, what you're going to usually see in the statement is of. And now great news is we know of tends to mean multiplication. So I may be multiplying with these values, or they may be multiplied and I need to divide. But these are the more straightforward percentages, right? Like I've got 78% of the test right. There's your of. Means you got 78% of the points. Or we may be talking what's called percent change. So in the world of percent change, you are going to see things like percent more than, percent less than, percent change. You can see this in ratios. I'm trying to think of other ways this says it, but I can't off the top of my head. But you're going to see these stated a lot of the ways, but it always is that. It's going to be how much more or how much less. So we're changing from something to something else. This is a little bit more complicated because I'm now going to be comparing how much they've changed to the original value instead of just one value to the reference value. Let's review some percentages. See if you know this. Press pause. Try it out. Our answers here are a half, 0.5, 1.4, 140%, 42, and 21 fifths. 50ths. Okay, if you got those, you can skip ahead to the next review question. If not, stay with me here. We're going to work these through. So how do we get those numbers? All right, it's important to remember that percent means per 100, right? Cent is 100, century, cents in a dollar, all of that. So when I am writing this with a percent sign, I'm already expressing this just as the numerator of the fraction over 100. So going from percents to fractions is actually the simplest one in terms of start with. I just do my percent in the top, then my per, and then my 100. And I drop the notation now because I've got it stated instead as a fraction and 100. Now I do want to simplify this. In your multi-view, you can do N over D and type the 50 in top, the 100 in bottom, and then press enter. And it will give you the simplified fraction 1/2. Now, how do I get that to a decimal? Well, if you've done it this way in your calculator, you can now just push the approximation button, and it will change it from a fraction to a decimal. Or you can actually do the division. So I can actually take the 50, divide it by 100, and get 0.5 or 0.50, whichever one makes you more comfortable. All right, how do I get 14/10 as a decimal? That's the easiest one here because I divide it. 14 divided by 10 is 1.4. How do I get it as a percentage? There's a few ways to do this. I can change 14/10 to 140 over 100 using fraction rules. And then then the percentage replaces this per 100 part, and I have 140. Does anyone remember the other big way to change? So if I have a decimal percent, which is what I have here as the decimal, I multiply it by 100 to get the percent. We're going to add to that in just a second. But remember, that's a big idea. You want that on your notes somewhere you can reference until you know it. Know it. All right, how do I get this 0.2 as a percent and a fraction? Ooh, you know this, right? So we now know if I have the decimal, I can multiply it by 100. And I have the percent. And then how do I get it as a fraction? It's 42%. Changes to 42 over 100. I'm going to simplify that the same way I did a second ago. So I'm going to do n over d, 42 in the top, 100 in the bottom, and get 21/50. If you know how to simplify fractions other than that by hand, you're welcome to as well. It's just not everyone's favorite. Okay, so notice shorthand back up here. 50% ended up being 0.5. How can we go that way quickly? Well, if I have the percentage, what I do is then divide by 100 to get the decimal. So see how those are related to each other? And we're going to call these percent decimals just so that it's clear that we're talking about this part of a value that's really, really important. But those are going to help you tremendously in the rest of this course. So start working on it. Make your good flashcard. Let's do this review problem. This is out of your homework. I usually get a few questions about it. So, how do I find a percent if I have the values? I am going to make sure that I understand what the reference value is. And the good news is the reference value tends to be the object of the preposition of. Okay? So that is not everyone's favorite English. Who knew that popped up in your math class? But you're going to see of, and you're going to see it referencing the reference value after that as its object. Now, that will leave you as a decimal, and you want a decimal percent, and you want an actual percent, so you'll multiply by 100 from there if I need to find a percent. The other thing we tend to do is work with a percent to find the parts. So this is where we're going to use the fact that of tends to mean multiplication, and we are going to work in the order of what we've been given. So I'm going to start right there. Suppose that 30% of female students and 40% of male students in a college history class are from a major city. If there are 50 female students and 30 male students in the class, then how many female and male students from that class are from a major city? Okay, so I want to know the number of female students that are from a major city. What I have right now is the number of total students and the percentage of female students. So I'm going to go ahead and write this down right here. This isn't something I would usually start my problem with in terms of writing it, but this is how I always start thinking through it. So 30% of female students is what I want to know. I'm going to replace both of those with really all three parts of this with something equivalent. So we know 30% is 0.30, right? Divided by 100. We know of tends to imply multiplication. And we know the number of female students in this class is 50. So I started with the idea in the problem, 30% of female students, and then just changed that to something that I could work with and multiply it. Other value we've been given is 40% of male students. And again, I'm just going to, from the problem, replace each of these with equivalent values. So 40% is 0.40. Of is times, and male students is 30. Now, you may have some kind of crazy percentage button on a calculator if you're using a weird one. Don't get comfortable with using it. The programming of it is really funky, and it won't help you later in the finance section. So there are 15 female and 12 male students, or a total of 27. We aren't given any other subgroups in this class, so that's what we're going to assume is there's just those two. That's finding parts given percents and wholes. This may not be the only way you've learned it, but this is the way I'm going to work it in our class. Okay. How about if they said, well, what percentage, and wanted you to find the answer to that, what percentage of the students in the class are from a major city? So to calculate percentages, we need to start with our ratio. So the of is referencing the students in the class. So the bottom needs to be the reference value, and it needs to be the total number of students in the class. So I need to add the 50 females and the 30 males, and that's going to give me 80. The number is from a major city. So this is my numerator, how many are in the major city. Because it's of the students in the class, that's my reference value, that is my denominator. So this is 27 from our last numbers. When I when I divide those, I get 0.3375. Do not round until you've changed it as a percent. Times it by 100 and I get 33.75%. And I may type it in that way, or they may ask me to round it to 1 decimal place or 2 decimal places, but don't round too early. Like if I rounded this to 0.34 and then I multiplied it by 100. Oh, sorry y'all, my pen's not working. And then I multiplied it by 100, I would have 34%. And if they then asked me for 2 decimal places, I'd be in trouble. So be careful of that.